Welcome to this Windchill showcase of Makersite's integration where environmental impact data is available in the Windchill interface. For our demonstration in Windchill, we are using a sub-assembly of the snowmobile, the engine and drivetrain system. This contains both buy and make parts, including material and weight data. We initiate the process of creating an LCA request to send the sub-assembly to Makersite for analysis. The first BOM we are sending is the production model. Once submitted, we see it process the request and then confirm that the request has been sent. Here we can see the LCA request is stored as an object. Once Makersite has completed the BOM analysis, it returns the PDF document that is added to the LCA request object and stored in Windchill. Looking at the PDF document, we can see a thorough analysis of the BOM. Our particular interest for this example is in the climate change total. In this example, we aim to assess whether the CO2 footprint of a specific subassembly can be improved. By clicking the BOM-related URL, we access Makersite for deeper insights and analysis. Once in Makersite, we navigate from the BOM homepage to the product model 1 of several Sankey diagrams available within the platform. Here we can view the complete BOM subassembly on the right with its constituent parts branching out to the left. Within the BOM, we identify the 700 Liberty engine subassembly represented by the longest line, indicating it contributes the most weight to the overall subassembly. Moving to the climate change total view, we see another Sankey diagram, but this time the horizontal line lengths represent the volume of CO2 within the BOM from both material and manufacturer. Here we can see that the Liberty engine has the highest CO2 contribution, clearly accounting for more than half of the total assembly within it. The crankcase and monoblock stand out as the components with the highest individual CO2 values. Moving to an automatically generated CO2 recommendation screen, we can see that some of the top recommendations are material changes to the crankcase and monoblock, as these are seen as the most impactful changes we could make to the overall BOM. Returning to the Sankey, there's also a grid view which we can sort by weight or CO2 impact. Once again, we can see that the Liberty engine is the largest contributor to CO2 emissions, with the crankcase and monoblock being the most significant components within it. Drilling into the crankcase, we see the material that has the largest CO2 value, primary aluminum. Here we can run a scenario where we switch out the existing material from a predefined list of alternatives to see their effect. Here we choose scrap aluminum. Once applied, we can see an estimated percentage change of over 16%. The Sankey diagram, based on our should cost model, also displays the estimated cost for the entire assembly. According to our production model, the should cost is projected at $12,000. To evaluate the material change proposed in Makersite, we refer the recommendation to our engineering design team for validation. If the material selection is approved, we then update the BOM in Windchill accordingly. In Windchill, we add an alternate monoblock and crankcase, which now uses recycled aluminum, and we can use filters to create a green variant of the BOM. We've labeled this configuration as the new green variant and submitted it for a Makersite lifecycle assessment for analysis. With the updated analysis returned, we can now view both the original LCA request labeled production model and the new green variant, each accompanied by corresponding PDFs and URLs. Upon opening the new PDF document, we can see that the assembly now generates 403 kilograms of CO2, compared to 668 kilograms in the original production model. Using the URL to break out to Makersite, we see the in-depth analysis of our new BOM. On the Makersite homepage, the Sankey diagram for the new green variant product model is displayed.